talking about a couple of things, right? You guys remember the other word that is used in place of the word slope?
Instantaneous rate of change.
No. Rate of change, okay? So a slope is a rate of change. It's telling you how the y's are changing as the x's are changing. Because remember the slope formula? What's the slope formula?
Oh wait, no.
No, that's the equation of a line. y2 minus y1
over x2 minus
x2 minus x1, right? So that's the change in y over the change in x. So it's something changing over something, right? For example, sometimes when we're talking about an object moving over time, so the position of that object is changing over time. Do you know what that's called? What rate that's called? Some of those of you that took physics? Velocity, right? Velocity is the change in position over time. Okay, so we're going to be talking a little bit about that and going into that stuff eventually. Today we're just going to kind of talk about rate of change in general. We're not going to call it velocity just yet, but velocity is a rate of change. Okay? There's average velocity and then there's instantaneous velocity. Average rate of change and instantaneous rate of change. Alright, so when we find slope, we had to find slope using how many points? 2. 2 points, right? So back in the day when we were in Algebra 1, your teacher would give you a point, right? Like let's say right here. And then they'd give you another point. And they would say, okay, find the slope between the 2 points. Do you remember that?
Yeah. It was terrible.
Yes?
Uh-oh, you're good off. Uh-oh.
Uh-oh.
A little off, I'm sorry. Try my best. Good? Alright, so this is what kind of a line? You'd say what? A secant line, right? So a secant line is a line that intersects how many points? 2 points. So it intersects the curve, which is the roller coaster, at 2 points. Anybody know what roller coaster this is? This is the Radler, before it became the iron one. Okay, this was actually still wood. This is at Fiesta, Texas and San Antonio.
How long that line is?
So, this particular, the slope of this line would be the average rate of change.
AROC.
Okay, so for simplicity, we're gonna say AROC, average rate of change. So to figure that out, we have to do y2, right? Minus y1 over
X2.
x2 minus x1. The basic slope formula, yes? That's telling us the rate of change. How is the speed of that roller coaster changing in this particular time here? You can. It's not really true for us to say speed, but how fast the roller coaster is traveling on average between those 2 time intervals is what it's giving us. Yes? Yes?
Yes, see.
All right. Now, using calculus, we discovered that we could find the rate of change at just 1 point, or we could find the slope at using just 1 point, right? That would be like finding the slope of a what?
Tangent line.
Of a tangent line, right? So that's a line that intersects the curve at one specific point. Yes? Awesome. So this right here, if I were to find the slope of this line, this tangent line, that slope would be called the instantaneous rate of change. IROC. Why do you think I'm calling it instantaneous?
So is that 1 point?
It's at that one particular moment in time, right? It's telling me how fast that roller coaster is traveling at 5 seconds. Okay, not over a particular period of time, at exactly that moment in time. It's kind of like when you go to San Antonio, right, and you're driving. Yes? You're driving your car, right? Are you traveling at the same velocity all the time? No, your speed is changing, right? You speed up, you slow down. But if you wanted to figure out the average that you traveled, you would get your starting time and your distance, right, which would be 0, your ending time and your distance, and then you would do the basic slope formula, and that would tell you how fast you traveled on average throughout that whole time period. Do you understand? Okay. So a popular problem regarding this is, for example, let's say you were driving on a toll road, right? Okay, and you pass a particular meter, and then you end up getting home, and a week later they send you a ticket in the mail, right? So you get a ticket in the mail that said you were speeding. How could they figure out that you were speeding?
The
Cameras.
amount of
there's
time.
cameras and they take pictures of like.
They got the instantaneous.
How fast you were passing over the point.
So
Like how-
they're monitoring when you get to each checkpoint, right? When you pass each checkpoint.
Houston.
So if I get from this checkpoint to this checkpoint,
You got there too fast.
I got there too soon, right? I got there too fast. So that means that I had to have been what?
Speeding.
Speeding somewhere along the way. Okay, so somewhere along the way, my instantaneous rate of change was higher than the speed that I should have been traveling at.
And they send you a ticket.
Okay, so they'll send you a ticket for that because they know you were speeding.
Oh, that's amazing.
Okay, and they can go to court and they can prove it to you using calculus. Okay, pretty cool?
That's pretty cool.
Cool, but
Yeah.
not cool.
Cool, but not cool for you, right?
Yeah, that's
Alright, so this is the instantaneous rate of change.
The Sherlock Holmes.
So how do I find the slope of a tangent line? So in order to do this, I need to be able to find the derivative at some particular value. Right?
Yeah.
That's gonna give me that instantaneous
We
rate
need a
of change.
smart board.
So for example, let's say they had a camera set up here, right? I don't know what a camera looks like.
You have one recording it after.
No, they have a camera set up here, right? And the roller coaster's coming down. They need to know the instantaneous rate of change at that particular moment in time to know whether this camera is gonna be able to take the pictures fast enough, right? To be able to get a picture of every section of the roller coaster. Yes? Do we understand? That's one application of instantaneous rate of change. There's many of them. Do we understand the difference?
Yes.
Alright, so now let me show you an example of an IROC. Okay, an IROC is the car I wish I had growing up in the 90s.
Oh my.
Nice.
It's kind of like a special edition of the Camaro. What do you think? Would I have been able to pick up chicks in that?
Yeah. That was like the.
What card?
Polar
Look at that, look at that. Convertible, that's a special one. That's right there, automatic girlfriend mode right there.
Why
Be married.
Well, as long as it isn't raining.
has to be married now.
Jeez, really? Alright, so, when I say the word IROC, I'm talking about what?
The average
No, not the car. The instantaneous rate of change. When I say AROC, I'm talking about the average rate of change. So those are the two different types of slopes that we have in calculus. The average rate of change and the instantaneous one. So we're going to talk about both of them, and we're going to learn how to work with them and how to describe what they're telling us, because that's the more important part for your test that's coming up.
Oh my
Wow,
Did you miss?
he missed.
That's all we put on around.
Okay.
It was so pretty.
So,
Showering.
remember that slope is just a rate of what? Of change, and there's two types. The first one we're going to talk about is average rate of change, and we know that it's the slope of a what? Secant line, and we need how many points? 2. That means we need an x and a y. Okay? We know that it's called what? AROC, average rate of change. What's the formula for average rate of change? For basic slope between 2 points? y2 minus y1 over x2 minus x1. Another way that this could be presented is in function notation. So like, let's say they give you the x's, a and b, and they say find the average rate of change in that interval, then that would be like saying f of b, which is y2, right? Minus f of a over b minus a. Okay? So if they give me an interval that they're just giving me the x's, right? How can I find the y's? I get the derivative to find y values?
No.
No.
You look at the graph, you
Let's say they just give us a function of it. How would I get y values if I knew x values? Plug in the x values, so that's why I wrote f of what? F of b minus f of a over b minus a. That's just the basic slope formula. Don't panic, okay? Okay, let's look at this example here. It says, in an experiment of the population of bacteria, find the average rate of change from P to Q and draw the secant line. Indicate the units of measurement. Okay, so we're looking for the slope of the secant line from where to where? From P to Q. I want the slope of this secant line that I just drew. What is this data comparing? What is the data here on this graph? The number of bacteria and the number of days, right? So the number of bacteria over the number of days. What's happening to the bacteria as the time goes by, as the days increase?
They grow.
So there's seems to be more and more bacteria as time goes by, and then what happens here? It slows down until it gets what?
The limit.
Gets to zero? No, the population is not zero. It stays constant, right? The bacteria is not growing anymore, but it's not going away either, right? It's staying the same value that it reached. Good? Alright, so what we want to know is that in this time period, on average, what was happening? What does it look like is happening? It should be increasing on average there, right? It's increasing more than it's staying constant in that particular time period. Alright, so let's see if that's really what is happening. Okay, so what would I use for this? Do I have to use a derivative or do I just use the basic slope formula?
Basic slope.
Basic slope formula, right? Because it's the rate of change over 2 points. Alright, so we need the two values. We have them, right? So let's find the slope or the average rate of change. AROC. What's it going to be here? What's y2? 340 minus 150 divided by 45 minus 20. M average. This is the average slope, the average rate of change. Okay, so you have a calculator, go ahead and use it. Yeah. So this will be 190
Number 22,
over 22, and then that should reduce to what?
95 or 11.
95 over 11. Okay, now whenever you're talking about problems like this, including rates, something real, you need to include the units of measurement. So what would this be? 95 over 11 bacteria per day, right? So this would be 95 over 11 bacteria per day. Yes? So what does that represent? What does that rate tell me?
Increasing.
It's increasing. What's increasing?
The amount of bacteria.
The amount of bacteria is increasing. How?
Because it's,
What do you mean, how then?
well, it's positive and then bigger than the
Okay, so it's increasing but how? How? At what rate?
95 bacteria per 11 days.
95 bacteria over
11 days.
11 days, right? Okay, or 95 over 11 bacteria per day. Do you understand?
Yeah.
Yes? Okay, so let's write that down. Let's write down that interpretation. So the population of the bacteria is what? Increasing at a rate of 95/11 bacteria per day from when to when?
Is it like the?
It's like 20.
From day 23 to day what?
50? No, 40.
45, right? Those are the 2 points that I found the average rate of change. So, on average, the population is changing, right? It's increasing on average at a rate of what? So maybe we should even put that over here. On average, comma, the population of the bacteria is increasing at a rate of 95/11 bacteria per day from day 23 to day what? 45. And I can say that it's increasing